Hello everyone. So in this video we will be writing a constraint in which we have, let's say, two variables a and b, and each of them are 8 bits long or have a size of a byte, and we have to write a constraint to make sure that among amongst two of these random variables only exactly 4 bits should be equal. So 4 corresponding bits should be equal, and the other remaining 4 bits should not be equal. So we have to write a system Verilog constraint to enforce such pattern and such relation between two random variables. So let's begin. We will name our class cons1 like we did in our previous videos. So let's begin with our random variables. First one is A. The second one is B. So we will begin with our main constraint. So here we have to do a certain comparison, a bitwise comparison in which we have to make it sure that exactly 4 bits should be equal or 4 bits should not be equal. So it is same for if you look at the other way, the 4 bits should differ. So to do that, we have several methods, but we will use XOR. So let's say if we do bitwise operation or bitwise XOR between A and B, then if the corresponding bits are not equal, we will get 1. If the corresponding bits are equal, we will get 0. And that is the basic function of XOR. So here, what we will do, we will use this and we will use a function called count_ones. So here, what will happen? So I am using count_ones. So count_ones will count the total number of ones, and the total number of ones of the resultant vector. So like you have said that since we are doing XOR operation, uh, if the corresponding bits are equal, then the resultant corresponding bit will be 0, else it will be 1. So let's say if we have something like this, and so here if you will do a bitwise XOR between them, so what you will receive? So first, since 0 0 is equal, you will receive 0. Since 1 and 1 is equal, you will receive 0. Similarly, for the third bit, you will receive 0, and for fourth bit also, both 1 and 1 are equal, so you will receive 0. But from here, you will see that it's 0 and 1, which is not equal. So if you will XOR those bits, you will get 1. For this also, you will get 1. For 0 1 also, you will get 1. For 1 0 also, you will get 1. So this is the result, what you will get. So we have to make sure that there are total number of 4 ones exactly, which will ensure that exactly 4 corresponding bits are equal while the remainder of the 4 are not. So it is not a strict requirement that the first 4 bits should be equal and the remaining one should be not. It could be at any other pattern, but we should have at least 4 number of ones. And the count one here ensures that the resulting vector of XOR, bitwise XOR, will have exactly 4 number of ones. So this is a very pretty simple constraint. So let's go ahead and write a post randomized function. And here we will try to print the A, and we will do that in binary. Then on the next line, we will print the value of B, and we will also print that in binary. So we will begin with our main test module. Let's declare the handle. Let's assign an object and let us randomize it. Let's say we want to have multiple runs. So what I will do, I will also use a next line here. Okay. Let's say we want to repeat it for uh, 5 times. And for 5 times, we will randomize the class. And I should refer to the handle. Here I am making a mistake. Else, it will trigger an error. So let's see whether our code have any typos by compiling it. Okay, we do have an error at line number 29. Okay, so there's a typo right here. I forgot to add the semicolon. Now it is running fine, so let's start the simulation. Okay, what we have here? So as you can see that in our first run, the A and B are exactly getting varied by 4 bits. So this, the first bit here from A and B are not equal to each other. Similarly, here the fourth bit is not an equal to each other, and the last two bits are not equal to each other. Similarly, in here, uh, the first bits, the first corresponding bits are not equal. The third corresponding bits are not equal, and the last two bits are not equal. And same goes for the other repetitions. Here you could see that the first bit is not equal, and then this particular bit here not equal, then this one is not equal, and then this one is not equal. So exactly four bits are not equal. Here also this is not equal, this is not equal, and finally the fourth one or the last bit is not equal. Here also the second bit is not equal, and the third bits are not equal. The fifth bits are not equal, and the second last bits are not equal. So this just proves that our constraint is working perfectly as for our implementation. So that's all about this particular question. I hope you find this video useful. Please stay tuned for more. Thank you so much.